MapCloud Prototype is a web-based application with the web service capability for mobile users or cloud connection. I use Grails framework, a Java Groovy-based service-oriented computing frame for Web 2 applications. For more information about Grails, please visit www.grails.org. MapCloud Prototype could work in two different modes, simulation mode and real mode. In simulation mode, MapCloud uses the modeling information from MATLAB and other simulators like CloudSim to make mobile users different mobility patterns like random waypoint mobility model and Manhattan model with different location for local and public clouds. I use the real GPS information for mobile users and cloud data centers. In real mode, each mobile application sends its log to MapCloud, and MapCloud uses this information for processing, for extracting location time workflow and optimal service allocation for mobile users. In my work, I did not have the real access to large amount of mobile users, so I used the simulation platform, but I used the real quality of service profiling of three different mobile applications like optical character recognition plus speech processing, video streaming and multimedia file sharing to drive and tune the simulation environment to study MapCloud performance. In this demo, I ran before MapCloud for 100 users near UCI campus with average speed of 10 meter per second with the random waypoint mobility model and Manhattan model. It means that 50% of them are using random waypoint mobility model and the remaining are using Manhattan model. So let's see the main controllers and modules of the MapCloud prototype. The first one is the MapCloud mobile user controller. It has all the information of the mobile users, for example, user ID, the center of mobility of the user longitude, the center of mobility latitude, RSA utility, BFS utility. As an example, see there are other information for that. Music utility that is derived from the simulation. And also it has the visualization tools. I use the Google Map for visualizing the different users' center of mobility location, which you can see is in the UCI campus. The second one is the MapCloud quality of services. This is basically all the information is a DB that stores all the information of the different services in public and local cloud or in two-tier cloud architecture. For example, the multimedia transcoder. It has some information about the service type, service ID, the unique ID for the service tier, which is in local cloud, and the service URL if you want to use the RESTful web services, longitude and latitude of the services, power consumption for the standard size of data, delay and the price of the service, and this is all some other information that is related to the music algorithm. Yeah. And the third one is the MapCloud setting. This is setting basically used for the MapCloud as the simulation environment. By making the new setting, we could use and set up number of mobile users cloud services with their geotags and run scheduler algorithms. For example, I ran about one for 100 users. I used the Manhattan random waypoint mobility model in Manhattan, and the number of service type and the location time workflow and the maximum power consumption and the area of the simulation, and there is some information that is related to the processing. And finally, the MapCloud analytics. It has the information, the performance information of the algorithm, running algorithms like random service allocation, greedy algorithm, music, and Gmusic for service sharing and group-based application. As you can see, for example, this pie graph shows the MapCloud algorithm processing time. For example, for the random service allocation, which is the fastest one and simplest one, is about the 11% of the total processing time. And greedy approach is the second one, and music and the Gmusic. And the second graph that I show you is the MapCloud performance result. It is compared to the brute force search algorithm or optimal algorithm or the optimal solution I mentioned in all of my papers before. For example, as you can see, for 20 users, music has about the performance of about 78%, and Gmusic has about the same as the 78%. And RSA about the 62%, and the greedy about 66%. And for 100 users, the music is about 72%, RSA is about 57%, and greedy 63%. Now that's it. Thank you for watching this video demo about MapCloud.